In this video, we are going to talk about callable bonds. So what are callable bonds? So far, when we talk about bond has fixed maturity date. So in callable bonds, there's a provision which says the bond can be called early if the issuer decide. But the callable dates are in the bond prospect. So in this one, bond can be called earlier by the issuer. Then those callable days are given in one prospect. So, the question become why someone won't issue callable bonds. The reason for this, the market rates can be different over the time. So the bond issuer may want to take advantage of that. So because of that, they may issue the callable bonds. So let's go through the introduction a little bit and then try to understand what more in detail. Callable or redeemable bonds are bonds that can be redeemed or paid off by the issuer prior to the bond maturity date. So that's the key part. It can be callable or redeemable earlier before the bond maturity date. The earliest such call date will generally be several years after issue date. So it's not like you will see the callable bonds in within like next week. It would be like maybe 2-3 years. So usually these bonds maybe more than 10 years, 20 years. Okay. The right of the issuer to retire the issue prior to the start maturity date referred as call option on the bond, hence callable bond. So you get the idea. The call option basically that give the right to the issuer. So that's why it's called the call option. Actually, there are another type of bonds which called the puttable bonds. We are not going to cover that, but in this case, since it's callable, there's a different one which is called the puttable bond. This one gives the right to the bond holder. If you're interested, you can search in this in textbook or internet. Right to bond holder. So callable bonds give the right to the bond issuer. Call dates are usually specified by the bond issuer. When the issuer call its bonds, it pay investor the call price. Typically, there is no one call price, but a call schedule which set for the call price based on when the issuer can exercise the call option. So when the bond is called, remember that when bond become mature, the bond issuer pay the maturity or redemption amount. In the same situation, if the bond is callable, in the call schedule, you can find what would be the redemption amount. Okay, so this can be the different from the amount you would get maturity if the bond hold until maturity. So may be different from maturity amount. What you get if bond is held until maturity. An issuer may choose to redeem a callable bond when current market interest rate drop below the interest rate on the bond. So this is when the issuer decide when the current market rates drop below the interest on the bond. So why is that? Because then, so market rate is less than coupon rate. So what is this? This means basically issuer paying back bondholder at higher rate. Think about loan, okay? So this is borrower. This is lender. Okay. So then it's look like you are paying high interest when the market rate are lower than the coupon rate. The coupon are more like interest payment, no? We learned that you can really divide coupon into the interest plus the principal. So if you are paying higher coupon, that means you are paying coupon, and the coupon rate is more than market rate. That means you are paying a loan at higher rate when you can borrow at lower rate. So this implies that um, issuer should pay off current loan or the borrower, let's say borrower, it should pay off current loan as soon as possible and borrow at lower rate. It is more like mortgage, no? So if the market rate become lower, then we would like to refinance our mortgage. The same way, if you're paying at higher rate to the bondholder through the coupon payments, why you do that if the market rate is less? For example, let's say your rate is 10% and the current market rate is 2%. So now you are for every $100 you are paying what? $10, no? In reality, you could have paid only $2. Okay. But you cannot get out of that commitment because you issued the bond. You promised them. So the only way you can get out of that promise, you pay off the bond, or basically you call the bond and pay the redemption amount, whatever the decided value under call schedule, and then you can issue new bond. Okay, so the idea would be call the bond, pay the redemption amount as explained in call schedule. Then borrow again at lower rate. So if I pay off this bond, which I promised 10% coupon rate, if I pay it off early, then I mean if I call the bond and pay off the redemption amount, then I can issue a new bond. But then next time I would say maybe my interest rate is coupon rate is now 2%. Okay, so new coupon. Or I can give something like 2.5 just to make it attractive. But I don't want to go to the all the way to 10% because that's put me in a disadvantage. So that's the idea of this callable bond. So the issuer can decide when to stop paying the callable. But this is also true in the other way. Like if market rate is higher than coupon rate, then you do not call. And that's the general rule. Why? Because then the next time you issue a new bond, you have to increase your coupon rate to match with the market rate. Otherwise, no one want to lend you money. Remember, the bond is in its primary form. It's you are lending, you lend money for the bond issuer. You are borrowing money. Okay, so because a bond is basically lend and borrow. Okay, that's that mechanism in there. Okay, so the borrower want to pay lower rate and the lender want the higher rate. Okay, lend at high rate and borrower need to borrow at lower rate. So that's the problem here. So if market rate is more than coupon rate, then as a borrower you are really borrowing at lower rate. You should not call bond and then issue new one. But if market rate is lower than the coupon rate, that means you are borrowing at higher rate. Why you do that? You can just pay off your loan or the pay off the bond right now and then issue new bond at lower rate. Okay. So that's the idea in here. So if the redemption value is same at any call days, including the maturity date, then the following general principle will hold. The call date will most likely be the earliest date possible if the bond was sold at premium, which occurs when the yield rate is smaller than the coupon rate. So if the bond is sold at premium, and then the call date should be earliest possible date. Okay, so why is this? So we know that P minus C equal G time C time G minus J A N J. Okay. So if the bond is sold at premium, so that means basically price is more than redemption amount. Then so that means basically we are saying G is more than J. Okay. So this is market rate. This is what you promise. Remember, G is modified coupon rate. Okay. If F and C are same, this would be R. So in a way, G is proportional to the coupon rate. Okay. So coupon rate or modified coupon rate is more than the market yield rate. So in that sense, in that case, you are paying higher than what market required you to pay. So you would try to call it early. Okay. So earliest date possible. The call date will most likely be the latest possible date if the bond was sold at discount. Okay, so sold at discount. Now this rule only valid if redemption value is same at any call date. Okay. If you have different redemption values, then you have to go through each and every one. Okay. So here's the question. This one says 15-year, 1,000 par bond has 7% semi-annual coupon and is callable at par after 10 years. What is the price of the bond to yield 5% to the investor? Okay, so right away, what is G? So it's par value bond. So G is par divided by C, which is R. In this case, it's semi-annual, so it's going to be 7% divided by 2. Then the rate J is what we want, 5%. And now we have to be careful because this G is for 6 months. And this J, I think it's given for annual. Okay, so let's calculate the 6-month effective rate. So 1 plus I square equal 1 plus J. So 1 plus I square equal 1.05. From here, I can calculate I. Let me my calculator. So 1.05 to square root. So it's 2.46. So that means basically I mean this formula. In this formula, this is my actually hit here. So you can see G is more than the yield rate. Okay. So G is more than J. I mean let me put like J star. Because J star is 6-month effective rate, which is basically I. So so this means basically sold at premium. Okay, because this entire term become positive. So that means P is more than C. Okay, sold at premium. So that means, and then the redemption amount is fixed for entire after 10 years. Always is called at par. So this should be what? This should be called at earliest possible date. So what's the earliest possible date? After 10 years. So then the price should be what? Price should be FR times AN J plus CVN. In here, now N is not 15. N is actually 10 because it's going to be called at earliest possible date. So we can calculate the price now. Price would be, coupon amount is for 1,000, it's 1,000 times 3.5. 35. So 35, 8, 10. The rate is this one, which we just found, 2.69. Plus C is 1,000. V to the 10. And V is 1 over 1 plus 0.02469. Okay. So let's use our calculator. You can actually enter this into calculator. You can say payment is 35. Future value is 1,000. N is 10. Rate is 2.469. COY POY is 1. And then you are calculating the percent value. Second, reset, enter. Let's enter this number, 35 for payment. 1,000 for future value. 10 for N. 2.469 for rate. Compute percent value. So I get 1,090. And I get 31 cents. So that is the price which we should use. So that is the price the bondholder should pay under this for this one. So here you will see a problem from exam FA. Bond X is a 20-year bond with annual coupon and following properties. Par value is 1,000. Coupon rate is 10%. Callable at par. Callable at par. So that's you have to pay attention on any of the last 5 coupon dates. Calculate the maximum purchase price for bond X that will guarantee an annual effective yield rate of at least 5%. So let's try to solve this one. This one says N is 20. So this is the first coupon date. So this one would be 15, 16, 17, 18, 19, 20. So any of these days, bond can be callable. Last 5 coupon dates. Okay, so par value is 1,000. The annual coupon rate is 10%. So coupon rate is what? 1,000 times 10%, which is 100. Okay. So after this, it can be callable at any time. Okay. So if it is called, then it's going to be called with redemption amount of 1,000. Okay. So 100 plus 1,000. These are possibility. Okay. Remember, it can be callable. Okay. So if it is called, then you get 100 plus 1,000. If not, until that you get the coupon payment. Okay. Until call or mature, you get coupon. So for example, if it's called at 18, then you would get the coupon payment 16 and 17. Okay. And then the 18, you get 100 plus 1,000. Okay. So calculate the maximum purchase price for bond X that will guarantee on annual effective yield rate of at least 5%. So we need the yield rate 5%. So the way to do that, if you can see that right away, yield rate and the coupon rate, this annual. So you can see the G, which is FR divided by C, F fancy same, R, which is 10%. It's more than the J, which is 5%. So that means this bond is sold at sold at premium, okay, because G is more than J. So sold at premium. So the bond is going to be called earliest possible date. So that means the year 16. So we have to calculate the price on this day. Okay, so since bond is called sold at premium, this bond will be called earliest possible date. So let's calculate the price. Price is going to be 100 if the coupon amount time A. We are going to have 16 coupon payments under rate, which we need 5%. Plus, when it's called, we are going to get the 1000. Okay, so here, this is the scenario. So will be called at time 16. V to the 16, and V is 1 over 1.05. So let's use our calculator. So in here you can see the payment 100. Future value is 1000. Rate is 5%. And is 16. And we are calculating percent value. So second, reset enter. So I would say 100 for the payment, 1000 for the future value, 5 for rate, 16 for in, complete percent value, and I get 1541 and 89. So that is the price you would pay, the maximum price. Let's do another problem. In here it says Claire purchased an 8-year callable bond with 10% annual coupon rate payable semi-annually. Okay, so basically coupon rate is 10% divided by 2, which is 5%. The bond has a face value of 3,000. So coupon amount is going to be 3,000 times 5%, which is 150. And redemption value of 2,800. So C is 2,800. The purchase price, assume the bond is called at the end of the 4th year for 2,900, provide an annual effective yield of 10%. Immediately after the first coupon payment, it received the bond is called for 2,960. Clear annual effective yield rate is I calculate I. So, the price was calculated based on this assumption. Under the assumption of what? You can see here, bond is priced, assume the bond is called at the end of the 4th year. Okay. So a bond will be called at the end of the 4th year. So what should be the price then? So we have the P. The coupon amount is 150. How many coupons by end of 4th year we are going to get? Every year 2, so we are going to get 8 coupons. And what was the discount rate they use? To calculate the price, they use 10%. This is annual effective yield rate. So we have to find the 6 month. So 1 plus J square equal 1.1, because the annual rate, I need 6 months. Remember the coupon is calculated semi-annual. So from here I can see J. Use your calculator. Let's see what you went with. 1.1 to the 0.5 now. Minus 1 times 100. J would be 4.88. 1. So that's the rate, 4.881 plus redemption amount was, they assume at the end of the fourth year, it would be 2,900. So V to the 8, and the V is 1 over 1.0488. So let's calculate using our calculator. So basically payment is 150, N is 8, rate is, the rate is 4.881. Future value is 2,900, and I'm calculating percent value. So 150 payment, 2,900 future value, 0, 4.881, 84N. Calculate the percent value. So 2,054. So that's the price. Okay, that's the price. But what happened immediately after the first coupon? Received the bond is called at 2916. So what happened? Actually, only one coupon paid. So if I write the formula, and they use the rate I, they want to find the rate I. So see, N. N was 1, actual experience. So I can write the price. The coupon was 150 and only 1. What was the callable value, which is 2960? And V1. V is 101 plus R. So we want to find the I. This is what we want to find. Okay, so you can see, and the calculate I. That's what we want to find. Okay. So again, this one we can enter into calculator. By the way, they want to calculate the annual rate. Okay, so this is actually not annual. This is 6 month rate. 6 month effective. Okay. So I can enter the present value is 2954.88. Enter negative value because you have to pay. That's the price you pay. Then the payment you will receive is 150, and the future value is 2960. N is 1, and we need to know the I over Y. Okay. So let me use my calculator. So 2954.88 probability. So that's the percent value. The payment was 150. Let me go back to the problem. I just want to see immediately after the first coupon payment, bond is. So I am assuming actually, so my assumption is immediately after the first coupon payment. So I'm not sure. So immediately after maybe you are going to receive the second coupon payment too. So here is 0, here is 1, here is 2. So this is the first coupon you received immediately after the first coupon. So that means that it's going to be called actually in the second one, no? So this should be actually 2. Okay, because immediately after the coupon received is called. So it's actually going to be called on the second coupon payment date. So so this should be 2. Okay, so let's use our calculator. 154 payment. 29604 future value. The price is 2954188. 24N. And compute 5.16 something. So now I need to write the annual rate. So this is what this is 1.0516 square equal 1 plus j. Or in this case, they use the notation I. So this one gives you the rate j, which is what they're asking in that question. So it's 10.58. Okay, so I'm going to stop here and when try to this problem. This one is really a good problem because you will see like different years. And then since it's, remember that rule that I mentioned in here, it's work only um, um, it's this principle is going to hold only if you have the same redemption value. Okay, when you have different redemption values, then that's not going to hold. So this problem you have to be very careful. Okay, so try this and contact me. Okay, so that's the end of this lesson.